Is it okay if I close the door? Alright, so guys, I'm actually going to do a few questions, grade 9 related questions, okay? Grade 9 related questions. So hopefully, if you are in grade 9, you guys have been getting a lot of attention from me, that's for sure. Grade 9s have been getting tons of attention, tons, like a lot more tons attention than you usually get, than I usually give to anyone else lately. Alright, so I have this question that I have there that you guys can see in front of you, okay? And I just want to take a moment and actually see if we can't take some time and go through this question. So this is for graphs, straight line graphs, because in grade 9, I know that some of you are actually writing in this week, and as some of you will be writing this week, there are questions that some of you have been sending through to me, that have to do with functions. So let me just remove this now. Hopefully we can see it. So here is the question that we are talking about. So we are looking at graphs, okay? And we are looking at specifically this question. This question is saying, find the equation of f and g. Now, something to note very quickly, guys, is that when we say f, all right, or f of x and g of x, yes, this is for grade 9 again. If we say f of x and we say g of x, what's important to note here, guys, is that f would be this line. That's f, all right, denoted by f there. G of x is this line, denoted by that symbol there. Okay, so these are two straight lines, all right, and I'm sure you guys can see that. All right, now something I want to just make clear very early is that f of x and g of x, f of x and g of x are simply what we call functional notation. And what it stands for for y. Okay, so f of x is just another way of saying y. G of x is just another way of saying y. All right, so this is just notation that we use. All right, when we read this, we say this is f of x, and then we say this is g of x, but what it actually stands for is y. That's what f of x and g of x stand for. Now, because here we have f and here we have g, this makes it so that we can distinguish between this line because it is f, and then that line because it is g. But then the minute we say f of x, understand that this is functional notation, which means y. G of x is just functional notation, which also means y. Okay, now you must have learned by now that a typical straight line function has this standard form. Okay, the standard form for any straight line graph or function is y is equal to mx plus c, where m is the gradient, okay, especially when the equation is in this form. We can simply read the gradient because the equation is in this form. The c is what we call the y-intercept. In other words, this C value will tell you where the graph cuts the y-axis. Okay? Gradient is what M is. C is what we call the y-intercept. In other words, the word intercept means it's where our straight line graph will cut the y-axis. That's why we call this the y-intercept. Okay? Intercept means to cut through. So that means where the straight line graph cuts the y-axis, that is called the y-intercept. And this value of C gives us the value of the y-intercept. Okay. M, on the other hand, is what we call the gradient. The gradient, what it is, guys, is simply a measure of how steep a line is. Okay? And our gradient can either be positive, which means when the gradient is greater than 0, or positive, then our straight line graph will be increasing. It will slope upwards. Okay? If M is positive or greater than 0. 2. M can be less than 0, which means the gradient is negative. In other words, our straight line will slope downwards if the gradient is less than 0 or if the gradient is negative. M can also be equal to 0. In other words, the gradient can be equal to 0, which means that our straight line will be horizontal. Okay, it will be a horizontal line, and the equation of that line, it will be exactly what the value of the y-intercept is. I repeat, the gradient will be equal to 0. This is grade 9, guys, grade 9, specifically grade 9, because we're dealing with straight line graphs. Okay, so the gradient is equal to 0. When M is equal to 0, we have a horizontal line. So that means we are going to have a constant y value for the horizontal line. Our y value is going to be the same throughout the horizontal line. That's when the gradient is equal to 0. Then lastly, number 4, our gradient can be undefined. When we say the gradient is undefined, guys, it simply means that our straight line is going to be actually vertical. Okay? And here, the equation will be x is equal to some constant value. In other words, the vertical line has a constant x value. The same value of x will be represented throughout this vertical line. Okay, so I'm just going to back up a little bit and re-explain what I've just said to begin this live lesson. Okay, I basically have posted a question here. The question says find the equation of f of x and g of x. But before I go into it, there's a few things I wanted to explain, and that is f of x is just what we call functional notation. It is a way of representing y. G of x is functional notation, and it is a way of representing y. Okay, the value of y, or y itself. F, different letter from G, because F represents this line, and then G is this line. Then, the standard form of any straight line function is y is equal to mx plus c. This is the standard form of a straight line function. Y is equal to mx plus c. The m is what we call the gradient. What is the gradient? The gradient is a measure of how steep a line is. A measure of how steep a line is. Another word for gradient is the word slope. Gradient is the measure of how steep a line is. Okay? It's what we call the slope of a line. So, if the gradient is positive, m, in other words, is greater than 0 in our standard form of the function, then we can expect a line that slopes upwards. Slopes upwards. Increasing function, in other words. That's what we expect when m is positive. When the gradient is negative, meaning it's less than 0, the straight line slopes downwards. In other words, we say the function is decreasing. It's a decreasing function that we get. If m is equal to 0, meaning the gradient is equal to 0, then we have a horizontal line. Yes, this is for grade 9. We have a horizontal line. I know I was meant to be a doctor in my past life. Thank you so much for the compliment. You are so kind. Street Life Remastered. Hopefully I can help you master the maths, and then you can ensure that when you write like a fine artist. Right? So m is equal to 0 is a horizontal line. Okay? Y is equal to the c value directly, because if the gradient is 0, then it means that gradient, which is 0, is going to multiply with the x, and it's going to eliminate, all right, this part of the equation. We are going to be left with c. And therefore, that means our y-intercept will be exactly the equation of the horizontal straight line. That's why we say that the value of y is constant for a horizontal line. So that's when the gradient is equal to 0. Then lastly, if m is undefined, what do you mean, m undefined? Guys, sometimes the gradient is not greater than 0, which means we don't have a increasing line. Sometimes the gradient is not less than 0, meaning it's not a decreasing straight line. Sometimes the gradient is not equal to 0, which means it's not horizontal, but the gradient is undefined. When that is the case, this standard form that you see here, y is equal to mx plus c, cannot hold. So when we write the equation for any vertical straight line where the gradient is undefined, we say x is equal to c. Because what is constant this time? Our x value is constant for any vertical line. So we say the equation of that line will be x is equal to whatever the x-intercept is for that vertical line. All right. So I hope you have noted the things that I've said here. Furthermore, if we now check what is the situation when we have parallel lines. If we have two parallel lines, what we have learned about parallel lines when it comes to the equation of a straight line. Parallel lines have equal gradients. Okay? Parallel lines have equal gradients. Okay? In other words, if the gradient of this line is known to me, let's say this is f of x, and then I ask what is the gradient of g of x if these two lines are parallel. Guys, then it means that if I know the gradient of this line, then it means that the gradient of this line, given that the two lines are parallel, would mean that the gradient of this line is the same as the gradient of that line. So we say parallel lines have equal gradients. We would say that the gradient of fx is equal to the gradient of g of x. The gradient of f of x will be equal to the gradient of g of x. That is what we know about parallel lines. Very important to note. Then secondly, we have perpendicular lines. What are perpendicular lines? Perpendicular lines are lines that intersect or meet at 90 degrees. They form a right angle where they meet. So if the gradient, let's say of f of x, and the gradient of g of x are there, what we know about perpendicular lines, guys, is that the gradient of those two perpendicular lines, the product of those two gradients should give us always -1. The product of what? Of the gradients equals -1. Product means multiplication, right? Of the gradient of the two lines should give us -1. Now imagine, guys, if I know that the gradient of g of x, let's just say for argument's sake, is 3, and I don't know what the gradient of f of x is, all right? I don't know what the gradient of f of x is. Then what I need to understand, guys, is that in order to find the gradient of f of x, I usually say to my learners, the shortest cut, okay? I know, guys, that we know gradient of g of x times the gradient of f of x should give us -1 as per the product of the gradients. If we multiply, we should get -1. So when you are asking yourself, 3 times what will give me -1, right? And I usually say to my learners, this thing is very easy to write. You know that the gradient here is 3, so 3 can be written as a fraction as 3/1, all right? Now, if you want to find the gradient of the other line, all you simply do is you flip this fraction, flip the fraction, and then you change the sign. I repeat, flip the fraction, change the sign. So 3/1, as you see it, right, will be written now as 1/3. So this is me flipping the fraction. Then 3/1 is positive. So that would mean if I change the sign of this number, 1/3, it will become -1/3. Isn't the multiplication of these two going to give me -1? Definitely it will. So this is the method that we can apply when we want the gradient of another line. If we know the gradient of one line, we are told that the lines are perpendicular, then all we need to do is we take the gradient of the given line, understanding that the two lines are perpendicular, we find the gradient of the other line by simply flipping the fraction. 3/1 becomes 1/3. Then since this was positive, we change the sign, so this becomes -1/3. So the gradient, guys, of f of x is simply -1/3, and that's it. When you multiply these two, indeed the product of the gradients does indeed lead to what? To a -1. So all in all, what I'm saying is that perpendicular lines, the product of the gradients of perpendicular lines should always give us -1, and that is something you need to hold very dear to your heart. Robin, you're asking me, do I do Euclidean geometry? And I'm guessing you're asking for grade 9. I did Euclidean geometry this morning. There's a video or a live session that I've just uploaded on the YouTube channel. You can go to my link, go to my bio right now, copy and paste the link, post it onto the YouTube channel, onto the Google whatever. So yes, definitely. Do I do Euclidean geometry? Yes, I do. Yes, I do. Grade 10, 11, and 12, if you basically are asking so that you can know fully. Yes, I do. Anyways, let us now try and go and answer the question. Maybe before that, hopefully we all know that we can find the equation of a line. If we are given that line, let's say we are given the line. Okay, this line is definitely not straight, right? Let's say I give you this straight line and I tell you that the coordinates there, the y-intercept is 3, and let's say I say the x-intercept is -4, and I say find the equation of this line. So first and foremost, whenever you want to find the equation, we must first write the standard form. What do we need in order to find the equation of a straight line? We need first the gradient, and we also need the y-intercept. So if I'm looking at this particular straight line, how am I going to find the equation? Guys, you can find the equation very easily and very simply and very straightforward to the point. M means gradient, C means y-intercept. Now, I'm sure you guys can see. I'm gonna suggest 2 ways to find the equation of this line. First and foremost, that point is where the graph cuts the y-axis. This is the y-axis on our Cartesian plane. This is the x-axis on our Cartesian plane. So right there, we have what we call as the y-intercept. The y value on this y-axis is 3. The corresponding x value on this y-axis is actually 0. So the coordinates there at that point, this point, are 0, x on the y-axis is 0, and then the y value on this point is 3. So we have a point, 0, and 3. Let's come here. This here is called the x-intercept, where the graph cuts the x-axis. What are the coordinates for this particular point? So here, on the x-axis, the x value here is actually -4. All right? And then the corresponding y value at this point is 0. So when we write the coordinates for the x-intercept here, we know it's -4 and 0. Those are the coordinates of the x-intercept. Are we together? Then here, on the y-axis, where the graph cuts the y-axis, the coordinates of the y-intercept are 0 and 3. You see? I hope we are together here. Now, if I want to find the equation of this line, I have what I refer to as the y-intercept. And the y-intercept, which is the c value, is actually 3, because the y-coordinate of the y-intercept is what I call the c value of the equation of the straight line. So I can simply say, to begin this question, y is equal to mx. What is the c value? The c value is a +3. So I can say 3. I've just substituted the y-intercept, the y value of the y-intercept, the coordinate itself. I've substituted the y coordinate of this point. Then I want to find the value of m. So what I do is I go and use the other point, which is -4 and 0. I am going to now substitute -4 and 0 so that I can solve for m. My x value is -4, my y value is 0. So what I do is that in the place of y, I substitute 0. M into, in the place of x, I substitute -4 plus 3. Then what I do is I transpose the 3. It becomes -3 on the other side. M times -4 is -4m. Then what I do is I divide both sides by -4. That cancels that. Therefore, m is equal to a negative divided by a negative is a positive. Okay. Negative divided by negative is a positive, and then this gives me 3/4. Therefore, I can conclude and say y is equal to, remember, the equation must have m. I need the gradient, which I've just found is 3/4, and I need the y-intercept. So I can now write the equation of the straight line. It's y is equal to 3/4x, all right, plus 3. And that is the equation of this line. Now, if you look at the equation itself, this gradient is a positive 3/4, which, if you look at the line, the direction of the line, this is an increasing line. For an increasing line, the gradient is usually positive. It's greater than 0. And rightfully so, my m value is positive 3/4. So therefore, it makes sense that we have a gradient of 3/4. X, of course, plus 3. The y-intercept is a positive 3, which also makes sense because where the y-intercept is, where the graph cuts the y-axis, it cuts it at positive 3. So I am very sure that this answer for the equation of my straight line is 100% correct. Okay, 100% correct. So this here, guys, is exactly what we mean by finding the equation of a straight line using the y-intercept if we are given it, and one other point. This is when you are given the y-intercept and one other point. You can find the equation of the straight line by exactly what I did here. Substitute the value of the y-intercept, which is 3, in the place of c. Since it's positive 3, that's why it's positive 3. But if it was negative 3, the y-intercept, I would substitute negative 3, and the positive and the negative would lead me to a negative 3 value of c. Then after that, you substitute the other point so that you can solve for m. You get the m value. Now that you have m and you have c, you can then go to the equation of the straight line, which is in standard form, and you go and substitute in the place of m the 3/4 that you got, and then x plus, you write in the place of c the c value that you had plus 3. This is the equation of the straight line, and that's that. Okay, so I think that is straightforward enough. Lisa Duda is like, I'm so glad I'm done with school. Hilarious. Okay, I saw someone saying in the comment section, can I please can you do the intercept method? Remember the intercept method do you recommend going over Euclidean geometry first or functions including trig? Doesn't really matter, Robin. Doesn't really matter. Doesn't matter, because the two topics are mutually exclusive. They are the two topics that don't have relationships really. So whichever one you decide to start with, you can start with it. Doesn't really matter, to be honest. Yeah, because both have concepts that you need to understand and grasp, and after you grasp them, you need to be able to then find your way, answer questions, and see if you can answer them well. Okay, guys, I want to come back to this question though, because all I was doing was just giving you some foundational understanding so that we can then answer this question. This question says we need to find the equation of f of x and the equation of g of x. So we want to find this equation of this line and the equation of this line. Now, how are we going to do that? Guys, let us look at the two lines. The two lines f and g. Let's look at f. You see f has a y-intercept. And we are given the value of the y-intercept. It is 6. So we know what the coordinates would be. Guys, if I write down the actual coordinates of this point, what will be the coordinates of this point? I want to see if you guys can actually give me the coordinates of the point. What would be the coordinates? How would I write them? What would they be, the coordinates of this particular point, where the 6 is? What are the coordinates? I want you to write down the x and the y coordinate for me for this point. And then also, we have this point as well. What is the x and the y coordinate for this point? Okay. Do we know, guys? Do we know how to write the coordinates for this point and that point? So hopefully we know though. So obviously for f, the function of f, we have 0 and 6. This point is 0 and 6. That's my coordinate of the y-intercept. Then here we have 3 and 0. So these are the points where this line is passing through. Okay? Yeah. So if you look at this line, I can find the equation of f. Okay? But if we look at g, can we find the equation of g? Can we start by finding the equation of g before we find the equation of f? If we look at g, guys, we only have the y-intercept, which is, as we can see it, has that point, only that point, which is the y-intercept, by the way, 0 and -3. But unfortunately, there's no other additional point that have been given on the line. So we cannot find at the moment the equation of g. So we need to first find the equation of f, and then we are going to use the relationship of the two lines. The fact that these two lines, they are perpendicular. We are going to use that information, because remember, we learned something about perpendicular lines. We learned that the product of the gradients of perpendicular lines should give us -1.